we looked at how to convert each x value into z value, the standard normal function, and then use the standard normal table to find the probabilities. But in Excel, we can circumvent that and go straight to the probability. You don't even have to compute z. You can go straight with x, mu, and sigma to find the probability. But if you like to compute z and then do it, both options are available. So Excel offers you two functions for normal probabilities. One is norm.dist. Now norm.dist assumes that you give the x value and the mean and the standard deviation, and of course you need to put comma 1 here for cumulative probability, because if you put 0, it's going to give you the height of the normal distribution function, which is of no use for us. We want only the cumulative probability. So it will always give you the cumulative probability if you use the norm.dist function in this fashion. Now if you compute the z yourself, like using this formula, then Excel offers you a second alternative, which is norm.s.dist. That s here stands for standard normal. So in that case, you don't give x or mu or z. You've already computed z yourself. So give z and then comma 1 again for cumulative distribution. So this norm.s.dist, this function is exactly like the standard normal table that we used earlier. Whereas this makes it even easier for us to compute the probabilities, because we don't have to do the z. You don't have to compute z. Okay. Now let's look at a numerical example. So we're going to use problem number 6.12. Here, according to the special report, US per capita consumption of soft drinks in 2013 was 42.2 gallons. Assume that the per capita consumption of soft drinks follows approximately normal distribution, and the mean is 42.2, and we are assuming a standard deviation of 13 gallons. So given this normal distribution, we want to compute these probabilities. Okay, let's first set up these parameters. Okay, so x is per capita consumption of soft drinks in 2013. And we are assuming that x follows normal distribution, and the parameters are 42.2 gallons and 13 gallons for standard deviation. Alright, so now let's compute some probabilities. So question A is, what is the probability that someone in the United States consumed more than 60 gallons of soft drink? So we want more than 60, remember that. So 60 is the x. Okay. Now to find z, we go x minus the mean, okay, and then divide by sigma. So that gives us the z value. Okay. Now if you want to use the normal table, so we take that 1.37 to the normal distribution table. Okay, 1.37 is here, 1.37 is right there, 0.9147. So 0.9147. So remember, this is the cumulative probability. Okay, this is the probability that x is less than or equal to 60, but we want greater than 60. So that means the probability is 1 minus. We can find this answer using the Excel function. If you want to use Excel function, then we do use norm.dist. Then we provide the x value, okay, and then the mean value and the standard deviation, comma 1 for cumulative. So this is the cumulative probability, x less than or equal to 60. Okay. Now if you wanted to use norm s function, so you go norm.s.dist, And we have to now give z. We have already computed z here. So comma 1. Again, the same answer. Okay. But this is the cumulative probability. So we need to do 1 minus that. We have to 1 minus that. That will give us the probability that a random person selected will have more than 60 gallons per year of soft drinks.